Question 1. G of x is equal to 3x cubed minus 20x squared plus k plus 17 times x plus k, where k is a constant. Given that x minus 3 is a factor of g of x, find the value of k. So if x minus 3 is a factor, g of 3 must be equal to 0. So all we've got to do is substitute in 3, make it equal to 0, and then solve for k. So we're changing x into 3. We've got 3 times 3 cubed minus 20 times 3 squared plus k plus 17 times 3 plus another k is equal to 0. So it's just a case of simplifying and solving for k. So 3 times 3 cubed, 3 to the power of 4 is 81. 3 squared is 9. So negative 20 times 9 is negative 180. 3k's are 3k. 3 17's are 51. Plus another k equals 0. Collect the like terms. 3k and 1k is 4k. We've got 81 and 51. Remember, you can use a calculator, but 81 and 51 is 132. 132, take away 180 is negative 48. So 4k minus 48 is equal to 0. Divide by 4. K minus 12 is 0. K is 12. K is equal to 12. Question 2. Find in ascending powers of x the first 4 terms of the binomial expansion of 1 minus 9x to the power of a half, given each term in its simplest form. So it's a binomial expansion. It's in the form 1 plus x. We've got a 1 here. So it's going to be 1 plus nx plus n times n minus 1 over 2x squared plus n times n minus 1 times n minus 2 over 6 x cubed. They're going to be the first 4 terms. And our n is the power, half. And our x is going to be negative 9x. So I'm just going to substitute n and x into this binomial expansion. So we're going to get 1 plus a half times negative 9x plus a half times n minus 1. So that'd be minus a half over 2 times minus 9x squared plus n times n minus 1 times n minus 2, which will now be minus 1.5 over 6 x cubed. So that's the expansion. Now it's just a case of simplifying, and we can use the calculator. So I'm just going to write each term into the calculator, but just leaving out the x, and I'll write the x on the end. So I've got a half times negative 9, that's negative 9 halves. So the first one's 1, then we've got minus 9 over 2 x. The next term, I'm going to have a half times minus a half over 2 times negative 9 squared. So I've typed it in exactly how it looks, just leaving out the x. Negative 81 over 8. So minus 81 over 8 x squared. And then the x cubed term. Again, I'm just going to type it in exactly how it looks. Instead of squared, I'm going to write cubed. It's now over 6. And on top, it was a half times minus a half times minus 3 over 2. So I get negative 729 over 16. and that's my x cubed. So that's my part A done. Give a reason why x equals negative 2/9 should not be used in the expansion to find an approximation for root 3. So why can't we use negative 2/9? So the reason is our expansion is 1 minus 9x to the power of a half. 1 minus 9x to the power of a half. The expansion is only valid when the modulus of 9x, the modulus of our x part, is less than 1. So the value of the 9x has got to be between negative 1 and 1. It can't be bigger than 1. And if you divide both sides by 9, we could say the modulus of x has got to be less than 1/9, or we could put it the other way around. X has to be less than the modulus of 1/9. So that x can only be between negative 1/9 and plus 1/9. That's the only thing we can use the expansion for. And minus 2/9 is not within that range. Question 3. F of x is x plus tan 1/2 x. Given that the equation f of x equals 0 has a single root, show that it lies in the interval 3.6 to 3.7. So this is substituting in 3.6, substituting in 3.7, and showing that one's positive, one's negative, so it's crossed at that point. So we're just going to grab the calculator. We're going to make sure it's in radians. At the moment, this one isn't. So change the angle unit to radians. And we're going to do f of 3.6, which is going to be 3.6 plus tan times half of 3.6. 3.6 plus tan times half of 3.6 is negative 0.686. And f of 3.7 is going to be 3.7 plus tan times half of 3.7. And we get 0.212. So we've got a change of sign. So we need to write there's a change of sign. And we also need to say that it's continuous in that interval. And f of x is continuous in the interval 3.6 to 3.7. Therefore, alpha lies in the interval 3.6 to 3.7. Part B, find f dash x, f prime x, the differentiator. So we've got f of x is x plus tan half x. F of x is x plus tan times half x. We need to differentiate. So we differentiate x, that goes to 1. Differentiate tan x. So when we differentiate tan, it goes to sec squared. And we're going to times by the bracket differentiated, which is half. So it's going to be plus half sec squared half x. So tan x differentiates to give sec squared x. Then we times by the bracket differentiated, which is a half. So it becomes half sec squared half x. Using 3.7 as a first approximation for alpha, apply the Newton-Raphson method once to obtain a second approximation for alpha. Give your answer to 3 decimal places. So I'm just quickly checking the formula book for the Newton-Raphson. So the Newton-Raphson iteration is xn plus 1 is equal to xn minus f of xn over f dash xn. So xn plus 1 equals xn minus f of xn over f dash xn. So using 3.7 as a first approximation for alpha, apply the Newton-Raphson method once. So we've got x2 is going to be 3.7 minus f of 3.7 over f dash 3.7. And we know f of x is x minus tan half x. And our differentiated one was 1 plus half sec squared half x. So we can't type sec squared into the calculator. So I'm going to do these separately. I'm going to do the top and the bottom, and then I'll save them both in the calculator as I go. So for the top, we've already done that. It's already in the calculator. It's 0.212. So I'm just going to store that as A. And then I'll move on to my denominator, which is 1 plus half of sec squared half of 3.7. So sec is 1 over cos. So it's 1 over cos squared half of 3.7. I put a bracket, cos times half of 3.7 squared. So whenever we have cos squared or sine squared, to type it into the calculator, you put the squared in a bracket around the outside. So that should be our denominator. So 7.58, I'll store that one as B. So it's 3.7 minus the numerator over the denominator. 3.7 minus the one we saved as A over our last answer. 3.672. Question 4. Given that y equals x squared, use differentiation from first principles to show that dy dx is 2x. And again, this is in our formula book. So differentiation from first principles, and it gives us a formula to use. So we can write f dash x is the limit as h approaches 0 of f of x plus h minus f of x over h. And f of x is going to be x squared, and f of x plus h is going to be x plus h squared. So we just need to substitute these in and then do some simplifying. So the limit as h approaches 0 of x plus h squared minus x squared over h. So it's a limit as h approaches 0. And expanding x plus h times x plus h, so double brackets expanding, x squared plus xh plus another xh, so 2 of the hx's plus a h squared, and then we've got minus x squared over h. So the limit as h approaches 0, x squared minus x squared is nothing. So we've just got 2hx plus h squared over h. And we can divide both of these terms by h. So the limit as h approaches 0, 2hx over h is just 2x. H squared over h is just h. So as h gets closer and closer to 0, what happens? Well, h becomes 0. We're just left with 2x. So as h approaches 0, h will become 0. So f dash x, our gradient, our dy dx, is 2x. And that is what we wanted. The function f is defined by f of x is 2x minus 3 over x squared plus 4. Show that f dash x, so again, differentiation, is ax squared plus bx plus c over x squared plus 4 all squared. So we're differentiating something in the form u over v. It's the quotient rule. So our dy dx is going to be v du dx minus u dv dx over v squared, where u is 2x minus 3 and v is x squared plus 4. So if u is 2x minus 3, du dx is that differentiated, which is just 2. If v is x squared plus 4, dv dx is that differentiated, which is 2x. So let's just substitute in. So f dash x is v du dx, so 2 times x squared plus 4, minus u dv dx, 2x times 2x minus 3, over v squared, x squared plus 4 squared. And we've just got to expand and simplify the top line. So 2x squared plus 8 minus 4x squared plus 6x. So that gives us, we want it in the form ax squared plus bx plus c. 2x squared minus 4x squared is negative 2x squared. We've got 6 x's and we've got 8. And it's over x squared plus 4 squared. So that's in the form we wanted. For part B, hence using algebra, find the values of x for which f is decreasing. So it's decreasing, it's going down when the gradient is negative. So we want to know where our gradient, which is what we just worked out, dy dx is our gradient function, is negative, less than 0. Where is our gradient? Negative. So if we times both sides by the denominator, it's going to disappear. So we're just going to be left with 2x squared plus 6x plus 8 is less than 0. We can half every term, but the calculator will actually do the work here. The calculator will solve this for us. Go to inequality, polynomial degree 2. It's the one that's less than 0. I've got minus 1x squared, 3 x's, and a 4. So x is less than negative 1 and x is greater than 4. X is less than negative 1, x is greater than 4. Question 6. Figure 1 shows a sketch of the graph with equation y equals 3 times the modulus of x minus 2 plus 5. The vertex of the graph is point P. Find the coordinates of P. So what's the minimum value we can get out of this? So because we've got a modulus, the minimum thing will be where the modulus is worth 0, and that will be when x is 2. So when x is 2, y is going to be 0 plus 5, which will be 5. So it's going to be 2, 5. The minimum point will be at 2, 5. So P is at 2, 5. Solve the equation. 16 minus 4x is equal to our graph. So when we have a modulus graph, it's actually two different lines. One with the positive version of the modulus part and one with the negative version. So we've actually got two separate lines here. I'm going to say this one is y equals 3 times x minus 2 plus 5. One with the positive gradient is 3 times x minus 2 plus 5. And the one with the negative gradient is where the bit inside the modulus is negative. So if that's negative, I'm going to write the negative on the front. Y equals minus 3 times x minus 2 plus 5. So if the bit in the modulus is negative, it's a different graph, and it's got the equation, it's got the gradient of negative 3. So instead of a positive gradient, it's got a negative gradient. So two different lines, and I'm going to work out where they both intersect with the line 16 minus 4x. So I'm going to make 16 minus 4x equal to the first line. 16 minus 4x equals 3 times x minus 2 plus 5. So expand the bracket. Get the x's on the same side. So plus 4x to both sides. And then we've got negative 1 on the right. So plus 1 to both sides. X is 17 over 7. And for the blue line, 16 minus 4x equals negative 3 times x minus 2 plus 5. So 16 minus 4x is minus 3x plus 6 plus 5. Plus 4x to both sides. Take 11 from both sides. X is 5. So we've got two answers. Do they both work? So is x equal 5 on the blue line? It is not. So x equals 5 is going to be over here. So x is 2 at P. So x is 5 is going to be over here. It's not on the blue line. So it doesn't intersect the blue line. It doesn't cross. But is 17/7 on the green line. Yep, 17/7 is bigger than 2. So 17/7 is on the green line. So that one works. So this is not an answer, but 17/7 is. So the answer is x is 17/7 only. Let's look at why that works. So if we had the graph of y equals 16 minus 4x, what would that look like? I have a y-intercept at 16 and a gradient of negative 4. So where does this one cross? It crosses at gradients 3, so that'd be 1, 8, 0, 11. This one crosses at 11. So if a graph has got, if it crosses at 16 and a gradient of 4, it's steeper than that line. It's coming down like this. So you can see it's never going to cross the blue part of the line, only the green part. A line L has equation y equals kx plus 4, where k is a constant. Given that it intersects at 2 points, find the range of values of k. So this line crosses down here at 4. And it intersects twice. So what are the options for its gradient? So it will intersect once if it passes through P. So that will be one intersection if it's there. And if it's got the same gradient as P, if it's got a gradient of 3, it'll be parallel, so it will never meet again. So it's only going to meet twice if it's between having a gradient where it crosses P and having a gradient where it's parallel. So it's got to have a gradient of less than 3, but bigger than whatever it would take to cross P. So it will meet P when, what's the gradient? So if it goes through 0, 4, and 2, 5, what's the gradient? So it's the change in y over the change in x, which is 1/2. So the gradient's got to be bigger than 1/2, but less than 3. So for part C, is it k? Yep, it's going to have to be bigger than 1/2 and less than 3. Question 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water. The water starts to leak from a hole at point L on the side of the tank. While the tank is leaking, the depth of the water is modeled by a differential equation. The HDT is negative 0.12 e to the power of negative 0.2 t, where t is the time after the leak starts. Using the model, show that h equals a e to the power of minus 0.2 t plus b, where a and b are constants to be found. So how can we change a dh to dt into a h? We're going to be integrating. So let's times by the dt. So we'll have just 1 dh equals negative 0.12 e to the power of 0.2 t dt. So we're going to integrate and get it in the form h equals. So h equals, when we integrate e, it stays the same, but we divide by the bracket, which is the power differentiated. So we're going to divide by negative 0.2. Negative 0.12 over negative 0.2 is 12 over 20, which is 0.6 or 3/5. Let's do 3/5 e to the power of negative 0.2 t, and then we're going to plus a c. And we can use the information we're given to find c. So what do we know? We know when t is 0, h is 1.5. So when t is 0, h is 1.5. So 1.5 equals 3/5, 0.6 times e to the power of 0, which is 1. So 0.6 plus c. C must be 0.9. So we have h is 3/5 times e to the power of negative 0.2t plus 0.9. Find the time taken for the depth to decrease to 1.2. So h is 1.2. What's t? 1.2 equals 3/5 times e to the power of negative 0.2t plus 0.9. So take 0.9 away from both sides. Divide both sides by 0.6. And to get rid of an e, we do the opposite. The inverse of e is our ln, our natural log. So ln 0.5 equals negative 0.2t. Divide both sides by negative 0.2, or times both sides by negative 5, however you want to think of that. So negative 5 ln 0.5 equals t. And I'll just type that into the calculator, and it should give me the answer. So negative 5 log 0.5, 3.46. T is 3.46 hours, and we want the answer in hours and minutes. So 3.46 is 3 hours, 28 minutes. We can also do that by timesing by 60. So change it into minutes and taking away 3 hours. So 3 hours and 28 minutes. In the long term, the water level in the tank falls to the same height as the hole. Find, according to model, the height of the hole. So what is going to happen to this as t gets bigger? So e to the power of negative a big number is going to be 0. So as t gets bigger and bigger, all of that part will be 0. So h will be left with 0.9. So 0.9 meters. We have to give a reason. Find, according to the model, the height of the hole. It doesn't say we have to. 0.9 meters. The functions f and g are defined by f of x is 4 minus 3x squared. G of x is 5 over 2x minus 9. Find f g of 2. So we're going to find g of 2 and then substitute it into f. So we've got 5 over 2 2's minus 9. 5 over negative 5 is negative 1. That's not the answer. We need to substitute that into f. So f of negative 1 is 4 minus 3 times negative 1 squared. Negative 1 squared is 1, so it's 4 minus 3. The answer is 1. Find the inverse of g. So the opposite of the g function. If we write it in the form y equals 5 over 2x minus 9, and then just make x the subject of the formula. So times by the denominator, y times 2x minus 9 equals 5. And we're just going to make x the subject. So 2xy minus 9y equals 5. 2xy equals 5 plus 9y, x is equal to 5 plus 9y over 2y. And now x is the subject. We have to change x and y back, so it's g minus 1 of x. The inverse of g is 5 minus 9x over 2x. And that is our answer. Find gf of x, given your answer as a simplified fraction. So we're substituting f into g. The whole of f goes into g. So gf(x) is 5 over, so we're changing x into the whole of f. 2 times 4 minus 3x squared minus 9, and we just need to simplify that. So expand will give us 8 minus 6x squared, and 8 minus 9 is negative 1. So we've got 5 over negative 1 minus 6x squared. I'm going to take the negative out. So it's the same as 5 over minus 1 times 1 plus 6x squared. And I'm going to write the minus on the outside of the fraction because it looks nicer. Deduce the range of gf of x. So what's the range of this? So what is the smallest thing I can have on the denominator? If x is 0, if x is worth nothing, it's going to be worth negative 5. So 5 over 1 is 5. So it can be worth 5. I'll just make a note of that. What if it was really, really big, the denominator? It would get closer and closer to 0. So we kept making it bigger. 5 over a million. It was negative 5, wasn't it? It was negative 5, and it can get closer and closer to 0. So the range is, it can equal negative 5, and it can get closer to 0, but it can never reach it. And it was called gf of x. gf of x. So when x is 0, that's the smallest thing we can get for our denominator. So the denominator will be worth 1. Negative 5 over 1 is negative 5. And as we put bigger and bigger numbers in for x, or bigger negatives, in for x, it's going to get closer and closer to 0, but it will never quite reach it. And function h, find the range of values for k for which f of x equals h of x has no solutions. So we've got f of x, 4 minus 3x squared equals h of x. And we want to know where that has no solutions. So let's make it equal to 0. So we're going to have 5x squared minus 6x, and then plus k minus 4. So it's got no solutions where b squared minus 4ac is negative. B squared minus 4ac is our discriminant. It tells us how many solutions a quadratic has. So where b squared minus 4ac is negative, there are no solutions. So b is negative 6. So we're negative 6 squared minus 4 times a, which is 5, times c, which is k minus 4, is less than 0. Negative 6 squared is 36. Negative 4 fives is negative 20, and we just have to expand that bracket still. 36 minus 20k plus 80 is less than 0. Let's plus the 20k. 36 and 80 will be 116. Divide by 20, 116 over 20, 58 over 10, 5.8 or 29 fifths. So it's where k is bigger than, what was it? 29 fifths. The first three terms of a geometric sequence are 3 to the power of 4k minus 5, 9 to the power of 7 minus 2k, and 3 to the power of 2 times k minus 1, where k is a constant. Using algebra and making your reasoning clear, prove that k is 5 over 2. So to go from one term to the next term of a geometric sequence, we times by a common ratio. So if we divide the second term by the first term, we should get the common ratio. If we divide the third term by the second term, we should get the common ratio. So we can say that the second term over the first term is equal to the third term over the second term. And I don't really want this 9. I want it all in powers of 3. That'll make it a lot easier for me. So I'm going to change 9 into 3 squared. So 3 squared to the power of 7 minus 2k over 3 to the power of 4k minus 5 is equal to 3 squared to the power of k minus 1 over 3 squared to the power of 7 minus 2k. When we divide indices, we take away the powers. So we can just rewrite these. So I'm going to take away the powers. I'm going to have 3 to the power of 2 times 7 minus 2k minus 4k minus 5 equals 3 to the power of 2 times k minus 1 minus 2 to the power of 7 minus 2k. Because they're both powers of 3, the powers must be equal. 3 to the power of this equals 3 to the power of this. So I can just get rid of the 3's and just write it as the two powers must be equal. And then we've just got to expand and solve. So 2 7s are 14. 2 times negative 2k, negative 4k. Negative 4k is negative 4k. Negative negative 5 is a plus 5. And that's 2k minus 2 minus 14 plus 2k. I'll collect the terms on both sides first. So 14 and 5 is 19. Minus 8k is 6k minus 16. Plus 8k to both sides. Plus 16 to both sides. Divide by 14. 35 over 14 is 5 over 2. Hence, find the sum to infinity of the geometric sequence. So the sum to infinity is a divided by 1 minus r. So the first term over 1 minus the common ratio. Do we know the first term or the common ratio? Nope, we're going to have to work them out. So k is 2.5. So a is 3 times 4 times 2.5 minus 5. Let's just type that into the calculator. It's 243. Let's let's just work out the second term. So 9 to the power of 7 minus 2, 2.5 is 81. And just, we may as well do the third term. 2 to the power of 2.5 minus 1, 27. So what's the common ratio? To go from the first term to the second term to the third term, we're dividing by 3 or timesing by 1/3. So A is 243. The common ratio is 1/3. So it's 243 over 1 minus 1/3. 243 over 1 minus 1/3. 364.5. Question 10. Figure 3 shows a sketch of part of the curve with equation y equals 8x minus x to the power of 5 over 2, where x is greater than 0. The curve crosses the x-axis at A. Verify the x-coordinate of A is 4. So if it crosses the x-axis at A, that means where it crosses x, y is 0, it's 4, 0. So if we just substitute it in, and the left side should equal the right side, and that will verify it. So y is 0, so 0 equals 8 fours minus 4 to the power of 5 over 2. And we can check it on the calculator. 8 fours minus 4 to the power of 5 over 2 is 0. For part B, the line L1, is the tangent to the curve at C. Use calculus to show that an equation for line L1 is 12x plus y equals 48. So we want the tangent at that point at A. So L1 is the tangent at A, so it's got the same gradient at that point. So we know A is 4, 0. So we've got 4, 0. We know the gradient at that point, so we're going to differentiate. So dy dx is 8 minus 5 over 2 x to the power of 3 over 2. So times by the power, take 1 off the power. When x is 4, when x is equal to 4, what is dy dx worth? Dy dx is going to be 8 minus 5 over 2 times 4 to the power of 3 over 2. So 8 minus 5 over 2 times 4 to the power of 3 over 2, it's negative 12. So now we know the gradient and we know a coordinate. So we can find the equation of the line y minus y1 equals m times x minus x1, where we've got x1 and y1 being 4 and 0. So y minus 0 equals negative 12 times x minus 4. We want to get it in the form where the x and y are on the same side. So expand the brackets and plus 12x to both sides. And that is our answer. L2 has the equation y equals 8x, and we've got a region bounded by the curve and the two lines, and we need to know the area of R. So use algebraic integration to find the exact area of R. So we've got two straight lines, 12x plus y equals 48, and y equals 8x. So we've got 12x plus y equals 48. We've got y equals, what was it, 8x? 8x. So what we're going to do here, we're going to find the area under the curve using integration. And then we're going to find the area of the triangle by doing half base times height. And then we'll do the area of the triangle, take away the area under the curve to find R. So we're going to need to know the perpendicular height. We know the base because A was at 4. So this triangle's got a base of 4. If we want to know the perpendicular height, we are going to need to know the intersection of these two lines. So y is equal to 8x. We can substitute that in. So that would be 12x plus 8x equals 48. 20x equals 48. X is 48 over 20, which is the same as 24 over 10, or 2.4. So when x is 2.4, y is 8 2.4s. So the coordinate here is 2.4, and then 8, lots of 2.4, which is 19.2. So it's 2.4, 19.2. So the height is 19.2. So the area is half the base times the height. Half times 4 times 19.2. Half times 4 times 19.2 is the same as 19.2 times 2. So we get 38.4 units squared. So that is the area of the triangle. We need to know the area under the curve so we can take it away. And that's integration. So between 4 and 0, integral between 4 and 0, 8x minus x to the power of 5 over 2 with respect to x. So we're going to integrate, add 1 to the power, divide by the new power. So that'd be 4x squared minus x to the power of 7 over 2, and then divided by 7 over 2. That's the same as timesing by 2/7. Substitute in 4, substitute in 0, and take them away. So it's going to be 4 times 4 squared minus 2/7 of 4 to the power of 7 over 2. Take away, if we substitute in 0, 0 squared, or 0 to the power of 7 over 2, are going to be 0. So we just need to substitute this in. So we have 4 times 4 squared minus 2/7 of 4 to the power of 7 over 2. 192 over 7. So we need to do 38.4, the whole triangle, take away the 192 over 7. So 38.4 minus 192/7 is 10.97. Or 384 over 35. I'll leave it as a fraction. Question 11. Figure 4 shows the design of a badge. The shape ABCOA is a semicircle, center O, diameter 10. So the radius is 5. OB is the arc of a circle, center A, and radius 5. So it's kind of like the same circle. Find the area of R. Give your answer in the form A root 3 plus B pi centimeters squared. So we have a radius of 5. That's a radius, that's 5. That's a radius. And that's a radius. So we've got an equilateral triangle here because they are all 5 centimeters. They are all the radius. And then this is also the radius. So we can find the area of the whole semicircle. And we'll find the area of a segment. So we'll do the whole sector, take away the triangle. Then we'll have 2 segments, the triangle, taken away from the whole shape. So we are in radians. So an equilateral triangle, each angle is 60 degrees or pi over 3 radians. So it's pi over 3. So the area of the triangle is half AB sine C. Area of the triangle is half times 5 sine pi over 3. We're in radians already. Half of 5 times 5 sine pi over 3 is 25 root 3 over 4. 25 square root 3 over 4 centimeters squared. I'll store that one in the calculator. Then we could work out a sector of the circle. So a sector of the circle is this whole shape. So it's the area of the circle, but only pi over 3, only that part of it, not the whole circle. So the area of a sector is actually a formula for sector area in radians. It's half r squared theta. So r is 5 and theta is pi over 3. So it's half of 5 squared times pi over 3, which will be 25 over 6 pi centimeters squared. So that's the sector. Then to find the segment, it's a sector, take away a triangle. So the segment area is the sector 25 over 6 pi minus 25 over 4 root 3 centimeters squared. So that's the segment. And so we've got 2 segments. We've got the area. We just need to take that away from the whole shape, which is, well, half of pi r squared, half of the whole circle. Semicircle area is half of pi times the radius squared. So we've got the semicircle, take away the triangle, take away 2 segments. So the shaded area is, that's right, 25 over 2. So 25 over 2 pi for the whole semicircle. Take away the triangle, 25 over 4 root 3. Take away 2 segments, take away 2 of 25 over 6 pi minus 25 over 4 square root 3. So that is the answer. It's not in the right form. We need to simplify it. So we just want something root 3 and something pi. Let's expand the bracket first. So 25 over 2 pi minus 25 over 4 root 3 minus 50 over 6 or 25 over 3 pi plus 25 over 2 square root 3. So we've got 25 over 2 minus 25 over 3 pi's. We can just use the calculator. 25 over 2 minus 25 over 3 is 25 over 6. So 25 over 6 pi's. And I've got 25 halves. Take away 25 quarters. Root 3's. So that's 50 quarters. Take away 25 quarters. It's 25 quarters square root 3 centimeters squared. Question 12. Express 140 cos theta minus 480 sine theta in the form k cos theta plus alpha, where k is greater than 0 and alpha is between 0 and 90 degrees. Change the calculator. Change the calculator to degrees. So it's cos plus. So cos plus, cos A plus B is cos A cos B minus sine A sine B. And we're going to change A into theta, B into alpha, and times through by k. So k cos theta plus alpha equals k cos theta cos alpha minus k sine theta sine alpha. And it was, what are we starting with? 140 cos theta minus 480 sine theta. 140 cos theta minus 480 sine theta. So let's compare these. So we've got cos theta in the first ones. So what's different? K cos alpha is 140. K cos alpha is 140. And for the second ones, sine theta, what's different? K sine alpha is 480. So to find k, we use Pythagoras. I'm going to quickly show you why. So if we square both of these, we'll get k squared cos squared theta equals 140 squared, and k squared sine squared theta equals 480 squared. If we add them together, so add the two equations together, so on the left we'll get k squared cos squared theta plus k squared sine squared theta equals 140 squared plus 480 squared on the right. And then we can factorize out the k squared on the left. And cos squared theta plus sine squared theta equals 1. So we're just left with k squared equals 140 squared plus 480 squared, so square root, and we get k. Now you don't have to remember where it comes from, you just need to know to find k, use Pythagoras. So k squared is 140 squared plus 480 squared, square root and we get k is 500. To find alpha, we divide the two equations. So sine over cos makes tan, and k over k cancels out. So tan theta is the sine one over the cos one. So we're going to shift tan (480) over 140, and we get 73.7 to 2 decimal places, 73.74. So we want to write it in the right form. K cos theta plus alpha, 500 cos theta plus 73.74. Part B. So a scientist studies the number of rabbits and the number of foxes in a wood for 1 year. The number of rabbits is modelled by R is equal to A plus what we just worked out, but instead of theta, we've got 30t, where t is the number of months since the start of the year and A is a constant. Given the maximum is 1,500, find the complete equation. So we're changing what we've just worked out. So we can change 140 cos 30t minus 480 sine 30t into our k cos theta plus alpha. So R is going to be A plus 500 cos, but instead of theta, it's 30t plus alpha. The maximum was 1,500. So for this part, it's 500 cos. So the maximum is going to be 500. The minimum's negative 500. So if we want the maximum to be 1,500, we need to add on 1,000. So A is 1,000. So now the maximum is 1,500 and the minimum will be 500. Hence write down the minimum. So the minimum is 500. 1,000 take away 500. The actual number of rabbits is at its minimum in the middle of April. Use this information to comment on the model. So when is the minimum? When is the minimum on the model? So it's the minimum when R is 500, or when the cos part equals negative 1. So cos 30t plus 73.74 has to be equal to negative 1 for it to be at its minimum. When's the cos graph at its minimum? It's at its minimum at 180 degrees. Shift cos negative 1 is 180. So 30t plus 73.74 is 180. So we're going to take away 73.74. So that's 106.26. That's 30t, 106.26. Divide by 30. So t is 3.542. So the actual number of rabbits is at its minimum in the middle of April, and it is the number of months since the start of the year. So it is the middle of April, 3.5 months since the start of the year, all of January, all of February, all of March, that's 3 months, half of April, so yes. Yes, 3.542 is the middle of April. The model seems to be suitable. The number of foxes in the wood during the same year is modelled by a different equation. F equals 100 plus 70 sine 30t plus 70. The number of foxes is at its minimum after t months. How many rabbits are there at this time? So the foxes are at their minimum when sine takes its minimum value. So sine 30t plus 70 will have to be worth -1. Shift sign -1. So that's -9t. So 30t plus 70 is -90 or 270. For the sine graph, the minimum is at 270. So take 70 away from both of them and then divide by 30. So we're going to get -160 and 200. We don't want the negative one. Divide by 30. 200 over 30 or 20 over 3. So that's t, and we want to know how many rabbits there are at that point. So substitute that back into the rabbits formula. R is 1,000 plus 500. Lots of cos 30t plus 73.74. And t is now 20 over 3. So substitute it in. And we get 1,033 rabbits is the closest number, closest whole number. 1033. So we substituted that in for t, and we get 1,033 rabbits. Question 13. Given that a is a positive constant, use the substitution x equals a sine squared theta to show that. So we're starting with the integral between a and 0 of x to the power of a half times square root a minus x with respect to x. We're substituting something in for x, and we need to get to half a squared times the integral between pi over 2 and 0 of sine squared 2 theta with respect to theta. So when we're doing integration by substitution, we need to change the limits. So when x is a, what is theta going to be? So when x is a equals a sine squared theta. Divide both sides by a. Square root. And when is sine theta equal to 1? When's the sine graph equal to 1? It's at 90 degrees or pi over 2 radians. And for the 0, we want the 0 equals a sine squared theta. Divide by a, that's 0. Where's sine theta equal to 0? It's at 0. So we're changing the limits to pi over 2 and 0. And I'm going to leave x to the power of a half times the square root of a minus x. And instead of dx, I'm going to write dx d theta, d theta. We just need to work out what dx d theta is and substitute in for x. So square root x, x to the power of a half. Square root x is going to be the square root of a sine squared theta. Dx d theta is a sine squared theta differentiated. So a is a constant. When we differentiate sine squared, it's the same as sine theta squared. So we times by the power, take one off the power, and times by the bracket differentiated. So times by the power, take one off the power, so the power is now 1, and times by the bracket differentiated, sine differentiated is cos. So dx d theta is 2a sine theta cos theta. And x we can change into a sine squared theta. X is a sine squared theta. So we should just be able to substitute all of this in and see what we get. So x to the power of a half is the square root of a sine squared theta. Then we've got the square root of a minus x, which is a sine squared theta. And dx d theta is 2a sine theta cos theta, and that's with respect to theta. So it's not quite how we want it just yet. So let's change square root of a sine squared theta. Let's square root them both separately. So have root a and then sine theta. Not sure what to do with this second square root. Going to leave that for now. Now I'm going to factorize out the a. Let's go back. If I factorize out an a, I've got a times 1 minus sine squared theta, which I can change into cos squared theta. So I'm going to change it into root a times sine theta times a cos squared theta, because cos squared theta plus sine squared theta. So because cos squared theta plus sine squared theta is 1, 1 minus sine squared theta can be changed into cos squared theta. And that's times 2a sine theta cos theta with respect to theta. Now I can square root the a and the cos squared theta. So I've got root a times sine theta times root a times cos theta times 2a sine theta cos theta with respect to theta. So I've got root a times root a, which is a, times 2a, so 2a squared. 2a squared. I've got sine theta times sine theta, sine squared theta, cos theta times cos theta, cos squared theta. This must be starting to look, we just want sine squared 2 theta. So sine 2 theta, that's another rule. So sine 2 theta, sine 2 alpha is 2 sine alpha cos alpha, or sine 2a, I should say, is 2 sine a cos a. And I've got 2 sine a cos a, haven't I? do I want that squared? I want that squared. So sine squared 2a, if I square both sides, is 4 sine squared a cos squared a. I don't quite have 4 cos squared a sine cos squared a. But if I half both sides, I'll work over here. So half of sine squared 2a is 2 sine squared a cos squared a. So I've got 2 sine squared a cos squared a. I'm going to change that into half sine squared 2a. So I've got a squared, let's bring that on the outside, times 2 sine squared theta cos squared theta, which I can change into half of sine squared 2 theta. What do I need to do? Just bring the half to the outside and it's done. So half a squared pi over 2, between pi over 2 and 0, of sine squared 2 theta with respect to theta. Hence, use algebraic integration to show that this is k pi a squared, where k is a constant to be found. So even if we hadn't done part A, we can still do part B because we've got the answer given to us for part A. So we're just integrating and we should get something in the form k pi a squared. So we're integrating sine squared. We can't integrate sine squared directly. We need to use our double angle formula. So it's the double angle for cos, so cos 2a is 1 minus 2 sine squared a. If you can't remember these formulas, you can always go back to the cos a plus b formula, which is given to you, and substitute in a plus a. So change b into a. So it'll be cos a minus sine a, which is cos squared a minus sine squared a. And if we want to get rid of the cos, get rid of cos squared a, we need to change it into 1 minus sine squared a. So 1 minus sine squared a minus another sine squared a is 1 minus 2 sine squared a's. So cos 2a can be written as 1 minus 2 sine squared a. So writing that the other way round, how can I write sine squared a? So plus the 2 sine squared a to both sides. I write theta. And take away cos 2a from both sides. Again, cos 2 theta. And then half both sides. So sine squared theta can be written as half minus half cos 2 theta. So we want to integrate sine squared 2 theta. So sine squared 2 theta is half minus half of cos 4 theta. So we're ready to integrate now. So it's half of a squared times the integral between pi over 2 and 0 of half minus half cos 4 theta with respect to theta. With respect to theta. So integrate, add 1 to the power, divide by the new power. So half theta. Cos integrates to give sine, but we want to divide by the bracket differentiated, which is 4. So dividing by 4 will be 1/8 of sine 4 theta. And it's between pi over 2 and 0. So we're going to substitute in pi over 2 and substitute in 0, taking them away. So half of a squared. Half of pi over 2 is pi over 4. Minus 1/8 of sine 4 theta. 4 pi over 2's will be 2 pi. Minus half of 0, which is 0, minus 1/8 of sine 0. The sine graph is at 0, and at 2 pi. So all we have is half of a squared times pi over 4. Because pi over 4 minus 0, minus 0, minus 0 is just pi over 4. So we're left with 1/8. What was the form we wanted it in? 1/8 pi a squared. Question 14. A balloon is being inflated. In a simple model, the balloon is modelled as a sphere. The rate of increase, we've got to write the differential equation. So the rate of increase of the radius, dr dt, is inversely proportional to the square root of the radius. So inversely proportional, k divided by the square root of the radius. And so write a differential equation to model this situation. That's what we've done. At the instant when t is 10, the radius is 16. The radius is increasing at a rate of 0.9 centimeters per second. Solve the differential equation to show this. So let's just make a note of that information. When t is 10, r is 16, and dr dt is 0.9. So times by root r times by dt. So r to the power of a half dr equals k dt. So integrate both sides, add 1 to the power, divide by the new power. K integrated with respect to t is going to be kt, and we're going to plus a c. And we know that when t is 10, r is 16, and dr dt is 0.9. So actually, if we substitute into dr dt, 0.9 equals k over square root 16. We can find k to be 4 0.9s, 3.6. So k is 3.6. And then we can substitute in to our new one to find c. So 2/3 of r to the power of 3 over 2 equals 3.6 tens plus c. So 2/3 times 16 to the power of 3 over 2 is 128 over 3. Take away 36, 20 over 3. So c is 20 over 3. So we get 2/3 r to the power of 3 over 2 equals 3.6 t plus 20 over 3. And that's not actually exactly what we wanted. We want to divide by 2/3, divide everything by 2/3. So let's just check. So divide by 2/3, that's 10. 3.6 divided by 2/3 is 5.4. Hence, find the radius when t is 20. So when t is 20, it's just a substitution. Times 20 plus 10, 118. So r to the power of 3 over 2 is 118. To get r by itself, we want to do both sides to the power of 2/3. So to cancel out the power of 3 over 2, we want the power of 2/3, the opposite, the reciprocal. So 118 to the power of 2/3 is 24.1 centimeters. Suggest a limitation of the model. So if we keep blowing up a balloon, eventually it's going to pop. So we can't keep, it's pretty big, isn't it? The radius of 24 centimeters, it's a pretty big balloon. It's probably never going to reach that far. The balloon will pop. Question 15. Show that k squared minus 4k plus 5 is positive for all real values of k. So we can complete the square and find the minimum point, find the smallest thing it can be. So k minus 2 squared minus 4 plus 5. K minus 2 squared plus 1. So the smallest value is when k equals 2. It will be 1. So k squared minus 4k plus 5 is greater than or equal to 1. Therefore, positive for all values of k, all real values of k. A student was asked to prove by contradiction that there are no positive integers x and y such that 3x plus 2y times 2x minus 5y equals 28. So there's no positive integers that make this true. The start of the student's proof is shown below. Assume that positive integers x and y exist so that this times this equals 28. If 3x plus 2y is 14 and 2x minus 5y is 2, they're not integers. So x and y are not integers because the simultaneous equations solve to give 74 over 19 and 22 over 19, so x and y are not integers. Show the calculations and statements needed to complete the proof. So we're looking for two things to multiply to make 28, where x and y are positive integers. So what multiplies to make 28? We can have 1 times 28 and 28 times 1, 2 14s and 14 2s, and 4 7s and 7 4s. 4 times 7 and 7 times 4. We can also have negatives. We can have negative 7 times negative 4. But because x and y are positive integers, so if x and y are, we're assuming x and y are positive integers, that means that 3 times a positive plus 2 times a positive whole number, it's going to have to be at least 5. So it's going to have to be 5 or more. So as x and y are positive, as x and y are positive integers, three x plus 2y is going to have to be at least 5. And it's going to have to be, so 3 times a positive integer plus 2 times a positive integer is going to be at least 5. There's no other way of doing that. So we can rule out a few of these. So we need to try 28 times 1, 14 times 2 we've already done. So we don't have to do that one. 14 times 2 is already done. We don't have to do 4 and 7. So there's only 2 more things to try, 28 and 1 and 7 and 4. So 3x plus either 3x plus 2y equals 28 and the other one equals 1, 2x minus 5y, or 3x plus 2y is 7 and 2x minus 5y is 4. So if we solve these simultaneous equations, 3x plus 2y is 28 and 2x minus 5y is 1. And 3x plus 2y is 7 and 2x minus 5y is 4. If we solve these simultaneous equations, find out what x and y are. If we don't get any positive integers, that means there's a contradiction. There would have to be positive integers, x and y would have to be positive integers, and if we don't get positive integers, we've got a contradiction. I should have probably said we're only trying whole numbers. So if x and y are positive integers, then 3x plus 2y must be an integer, and 2x minus 5y must be an integer. So these are all the integer options. So let's solve these simultaneous equations. I'm going to use the calculator to do it. So I'm going to go to equations, simultaneous, 2 unknowns. 3x plus 2y is 28, and 2x minus 5y is 1. We get 142 over 19 and 53 over 19. And of course they are not integers. And the same for the second one. 3x plus 2y is 7. 2x minus 5y is 4. 43 over 19 and 2 over 19. And again, they are not integers. So there is a contradiction. Therefore, there are no positive integers, x and y. Therefore, there are no positive integers x and y such that 3x plus 2y times 2x minus 5y equals 28.